All right, everyone, let's get the show started. Welcome to our DevOps office hours. It's October 7th, 2020. My name is Eric Osterman, and I'll be leading the conversation. I'm the founder and CEO of Cloud Posse. We're a DevOps accelerator, and that means that we help companies own their infrastructure in record time by building together with your team and then showing them the ropes. If that sounds interesting, head over to cloudposse.com/quiz to get started. Again, that's cloudposse.com/quiz to get started. For those of you new to the call, the format is very informal. My goal is to get your questions answered. So feel free to unmute yourself at any time if you want to jump in and participate. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by going to cloudposse.com/office hours. Again, that's cloudposse.com/office hours. We host these calls every week. If we'll automatically post a video recording of this session to the Office Hours Slack channel, as well as follow up with an email that you can share with your team. So with that said, let's kick this off. I have lots of interesting little announcements or things that I came across. And we also have a special surprise pop-up guest speaker, Mr. Anton Babenko himself, to talk about serverless TF. He saw the mention last week and wanted to give a proper introduction to it since I was not able to. All right, so the first thing that I thought was kind of interesting, I'm going to jump out of full screen here, was this one here, which is AWS has just announced the ability to do intra-bucket, so within one bucket, multiple object owners. And what's interesting about that is in like a data lake kind of setting where you might want to have all your ingestion pointed at one bucket, but have different teams have ownership over objects in that. So one team cannot in any way impact another bucket. That means you can also, teams can manage their own IAM on those objects without affecting others. So I haven't looked into it deeply. This was the gist of what I got. I thought it was kind of interesting, and I'll share the link in the channel. Anybody see this announcement, get anything from it that I didn't emphasize? All right, so then going back here. So I came across this as I was cyber stalking another GitHub organization and their cool tools. So VMware has this organization called K14S, which is a collection of interesting tools for Kubernetes. Small, very purpose-built tools. Not, I mean, I thought it was kind of interesting, like their K-app or CAP app, which was a simple declarative way to describe an application, its dependencies, and raw YAML resources. It's kind of like a combination of Helm and Helm file, all in one tool. But I don't think it's anything we're going to adopt at this point, but I thought that was interesting. The thing that I found more interesting was vendor, which is a play on words, right? So vendoring is the concept of localizing source code in your repository so you don't have as many external dependencies. Charlie, no? Sorry, my dog. So what this tool does is kind of, well, if you've ever messed around with Git submodules or Git subtrees, you've maybe encountered the need or want to do vendoring, but also realized how obtuse it is to use the Git tooling and all the subcommands. It's just insane. So what this does is it takes a modern approach to vendoring where you have a file like the package.json with all your dependencies, and this is the spec. So you can specify a number of remote sources. It can be file paths, it can be Git paths, it can be HTTP paths or image locations like Docker images. And it will, and you can do version pinning and all that stuff, and then it'll extract all those files and resources into your local path. You can imagine this might be interesting like with Terraform, where you'd want to vendor a whole bunch of modules into a project for distribution and offline support. This is one way to manage that. Any questions about vendor?
Yeah, I wonder why there is no mention of Terraform inside the project itself, because Terraform sounds like native use case for this tool.
Yeah, it is almost. And like there was a project by Uber called Astro, which is like a TerraGrunt alternative. And one thing I had opened an issue here. I remember years ago now. Maybe they even closed it. Oh, maybe I didn't open it here. I thought I opened it here for vendoring. But yeah, you're right. Terraform is a native, is a pretty good use case for it. That said, and I went down the rabbit hole for this for a client project about a year and a half ago for Terraform vendoring, is if you use submodules that are remote, meaning not local, like submodules, then the recursion of that and vendoring all those dependencies isn't solved by a tool like this. And it gets really ugly and complicated when you got to think about that you might be including lots of remote modules, some that are the same but pinned at different versions. And that was like the dead end we hit when we originally tried to approach vendoring. Cool. So let's see here. I'll go ahead and drop that and the other link in the Slack channel here.
I feel like for Terraform vendoring, you almost have to run Terraform init and then just take that directory that it creates and
Yeah.
package that up.
And it's gotten a little bit better, right? I haven't looked at it too much lately, but it's a little bit more intelligible what all the paths are um, in it now. So where's office hours? Forgot to get the channel up. All right, so there's the second link, and here is the first link that I shared. All right, so let's move on then. The other exciting announcement is a buddy of mine is the founder of Scalar, and Scalar has moved into the Terraform space and come up with a Terraform cloud alternative. While it's not entirely feature complete with Terraform Cloud, they do have a lot of similar offerings. So, for example, what's rad about Terraform Cloud is the remote workspace functionality, right? So when you set up the backend provider, you can point that to Terraform Cloud. Well, they've reverse engineered the Terraform Cloud API, or I don't know if it's public, but maybe it is. But so it supports that way of working. So it's really a drop-in replacement for Terraform Cloud in that sense. It also has, it's using OPA, Open Policy Agent, behind the scenes instead of Sentinel. So I like the embrace of multiple open source packages. And I believe you can bring in your own container as well, which is a big problem with Terraform Cloud, is that it's hard if you depend on other tools to integrate those into your workflows. That said, I have no idea if you can use like TerraGrunt with it. And I think that would be one way for them to appeal to a pretty large group of advanced users. Anybody know that answer or not, if it works with something like TerraGrunt?
I talked to Scalar probably like half year ago,
Mm-hmm.
and their solution is like direct competitor to Terraform Cloud. The thing is that their solution is also not free, same as Terraform Cloud. So if you
No,
want
that's
to bring your Terraform Cloud agents, you can do this. You just have to pay money.
yeah.
So
No, it is a SaaS. It is a commercial offering. It's not open source like Atlantis. And for those, I've kind of started letting or sharing a little bit more about my frustration using Atlantis in concert with other continuous delivery systems and like the state of GitOps. So that's why I'm looking for other options. But you're right about that. However, on pricing, if anybody has had to deal with HashiCorp on pricing, I haven't heard one positive experience ever. I've never said, "Oh yeah, they came out and said wow, they gave us this amazing pricing, or they didn't make us jump through a bunch of hoops talking sales, never, right? So, they're trying to, do value-based pricing and figure out, what's it worth to you and charge you based on that. And, it starts at like 100K or whatever. I don't know, because I can't get any pricing. Or talk about it if I did. So what I think is awesome about Scalar, what they're doing about this, and it appeals to other developers and engineers as myself, is transparent pricing. No mandatory contact sales for pricing. No SSO tax. This is another pet peeve of mine. Is all these services that double, triple, quadruple, quintuple their prices when you want to enable single sign-on. So they're not charging extra for single sign-on, which is admirable. I like that. So I think we'll probably have them eventually on office hours at some time. Oh, is this not? I guess it's not public anymore. They were working on transparent pricing, showing what their price is relative to all the other cloud providers of Terraform backends. There's a few others out there as well.
Yeah, and talking about
Sheldon has it.
Terraform cloud providers, there recently has been also news from Spacelift.
Okay, yeah.
I don't know if you guys received an email, but
yeah. Spacelift, Spacelift also wants to come on. Maybe this is how we can do it. It'd be really interesting to have both Spacelift and Scalar on to talk about this stuff from their perspective and differentiate themselves.
well, but why limit to just two? We can bring M0 as well.
M0, I don't know about that one.
Eric, you should have attended my live stream. My live stream.
My bad. Is it this one here?
Yes.
Nice. Tell me about M0 in a nutshell.
Yeah, in a nutshell, they're providing you self-service and try to limit and try to give you controls to limit your budget and access controls.
Okay.
And they are really thinking about giving you templates which you can select from.
Okay.
So you have developers and you have users.
Yeah.
So that's how they differentiate. And also you can see $0 per month.
Yeah, so they have an introductory, some pretty competitive interactive. And then the beloved Let's Talk. All right. No, that's cool. Thanks for putting that on my radar. I'll post that in the channel as well. And we'll probably talk more about that another time. In the interest of time, I'll pause right there and move on, but that's cool. Let's see here. Okay, yeah, just one other thing I stumbled across is that there is actually a early release of a CodeFresh provider. We have been pretty big on supporting CodeFresh as a continuous integration and delivery platform that's Kubernetes first, Kubernetes native kind of solution. And what's nice about this is a way to manage then your whole Terraform account with code the way we would Terraform Cloud or AWS or other things. Haven't yet kicked the tires on it, but we do have a CodeFresh channel that they do monitor on SuiteOps. So if you do try it out and run into problems, like you, Andrew, maybe, I'm sure that they'll respond.
We're going to be using it for real here coming up shortly.
Oh, very cool. Very cool. So yeah, maybe this provider will be useful. Maybe this will be useful for you then. The other quick thing I saw in my feed was this, which is basically anomaly detection for AWS pricing or cost or cloud spend. This is interesting to me. We have another partner, Cloud Posse, called Taloflow.ai, which does like this plus a lot more bespoke solution. But the idea is this: is that there are so many products these days, like M0 that you were pointing out. I think Spacelift might be doing this as well. I think some other provider, even Terraform cloud is doing this to some degree. It's estimating what your spend is going to be before you click the button and apply. And I think that's pretty cool and probably pretty hard to do well behind the scenes. But generally, I feel like that is the wrong step of cost optimization. Maybe if the company is incredibly cash strapped, you might want to push back at that point. But I think a better way of doing this is deploying it, establishing a baseline, establishing the value, and then figuring out the cost, and then identifying anomalous costs. For example, suddenly your S3 bucket is costing you $1,000 a month when last month it was $100 a month. So being notified of those things that are changing and pointing those out, because in a large complex system, it's overwhelming the number of signals that you get. So as one way to stay on top of it is staying on top of the signals that are changing and standing out. They bring up some other explanations here that you basically don't want to get in the way of your team revving, and you can fix cost after the fact. There are a lot of controls at your disposal to optimize cost. Not deploying it might not be the best choice.
I have something to add here. So while you mentioned that there is Terraform Cloud and many other cloud providers or Terraform providers who take care of costs, there is also a free service, which is terraformcostestimation.com, which I run.
Interesting. Oh, you run it. Yeah, cool. Okay, hold on. Let me let's Terraform.
I sent link into cost estimation.
All right.
So the purpose of this service is actually, as you summarized, is to know things in advance. Mm-hmm. So yes, this is website, but if you go to the link to repository, then you will see how you can call this from your Terraform plan. So the way how I do this is that I can calculate price from any plan file or from Terraform state file. Mm. So that it's pretty tricky to do, and also
this must have been many sleepless nights to get right.
Yeah, and I also don't need all of secrets, despite the fact that people send them like crazy.
Yeah.
Because people just send the whole state file. Yeah. Here is a section which explains you how to remove these secrets and how to send anonymized cost keys, which are relevant for cost estimation. So I use the thing which this project does is that it removes all crazy things which contain secret, and they just generate cost keys, which I do look up on my end.
That's cool, and check out this domain. That's pretty sweet.
Yeah, and also that's actually a case for CI, exactly this line. So if monthly to number more than 10, then it is expensive. Then don't deploy this.
That's any idea how this compares with infra cost? I pasted the link in the Slack.
Yeah, infra cost does it for real. I do it for fun. That's the only thing.
Yeah. That's cool.
I mean, they made the whole company from that. So I assume that they do this much more sophisticated than the way I do it.
Infra cost seems to be free and open source. I've seen no pricing on their website. That's why I'm a bit confused.
No, there is something behind it. Maybe there is some company behind it who get some value from it. So yeah. So Terraform cost estimation was something what I wanted to have fun during weekend, but
infra cost API key.
Exactly. So that's the challenge which I face myself, is that only AWS take care of prices. Like literally, there is no API to find information on majority of other providers.
Right. No,
and true. That's something what I have no clue how to solve, like in scalable way. If you guys have any ideas where to get prices for Azure or for Google, please let me know. I have no clue where to find this information. I didn't find any API.
And on the back end, you created some kind of a data model where you're tracking those prices?
Well, I imported it once and then updated it another time, and then I forget about this project.
Yeah.
I don't have time to do this really, and I'm
Yeah.
glad that there are companies who do this for real, like InfraCost.
Yeah. Yeah. Just reiterating what Sheldon says here. Thanks for sharing. You're always doing so many freaking cool things.
Well, we just started. Come on.
Yeah. So let's see here. Any other questions on the anomaly thing or Anton's project there on cost estimation with Terraform? Okay. Then just another honorable mention here. A longtime listener is Mr. Andrew Roth. Congratulations on pushing. I'm guessing you were 99% behind this and also
Yes.
creating this new SAIC or open source organization.
I've been squatting on it for 2 years.
You've been fascinating. So interesting, and then you've been pushing it through the organization and finally got buy-in, and then now it's official.
Yep.
Very cool. I remember, who was it? Was it you, Sheldon?
Presentations to CEO or CTOs of Fortune 500 companies are a little scary.
Yeah, I bet. It came up, it was a couple months ago now, or a few months ago, like how to get your company to go along with open source and start open sourcing things. And I forget who asked it at that time, but
yeah, that was me, Sheldon.
yeah, okay. I thought it was you,
Yep.
Sheldon. Yeah. So yeah, you should definitely hit up Andrew for his game plan.
Excellent.
So Andrew, tell us a little bit about this module that you've worked on here. Looks like it's spinning up a Rancher master cluster using the AWS and RKE Terraform providers.
Yeah. So SAIC is a services contractor for government agencies. So Defense Acquisition University is one of our customers. And they had a requirement that they needed to be able to have their students be able to log into a DevSecOps environment and be able to do things for themselves, which would mean, here is a username and account or a username and password for GitLab and Jenkins and SonarQube and whatever else. And so this is the base of, this is one of 4 modules that go together to create an ephemeral virtual training range that lets you spin up a Kubernetes cluster with GitLab, Jenkins, SonarQube installed in one command, use it for class, and then tear it down.
Gotcha. So yeah, fully self-contained
Yep.
Environment that comes up in one fell swoop.
And they requested that we open source it so their students can use it whenever they want to after class. So
that's a good call. Yeah.
We have done that.
So you're using task file?
Yeah, we've been using task file for about 2 years now, and we absolutely love it. It's the gold standard for this kind of is Make, right? But
yeah,
it's got a learning curve, a big one.
Yeah.
And we've found that task file is a lot simpler to get people spun up on when they're new to a project or just new in general, junior developers who are coming on.
Yeah. Yeah. So, I mean, it's very simple, like straight translation almost from Make into a more descriptive schema here in YAML.
Yeah.
Which is cool.
We use Anton's pre-commit hooks extensively. We love them.
Yeah, I think half the Terraform community does.
As far as I remember, Andrew, by the way, you was one of the first contributor to pre-commit hooks back in the days.
Oh yeah, that's right.
I think you still have some pull requests open.
I probably do.
So yeah, that's how it is.
Yeah, that is. Yeah, pre-commit, that we should have that's a good talking point for a follow-up session is some good pre-commit hooks.
I don't know what I'd do without it.
Yeah.
without pre-commit. It's all of our repositories have pre-commit. It's one of the standard things that we add to every single repository.
That's cool.
I'm
Commit is saving lives.
I'm planning to have a session or live stream with the creator of pre-commit itself.
Oh, cool.
So it should be pretty interesting to talk about pre-commit itself, how it is used in the wild, and how we use in our Terraform live.
Yeah, that would be interesting.
Yeah.
So yeah, one other last announcement, then we'll get straight into Anton's demo of serverless TF, which I'm excited about, or not demo necessarily, but overview. All right, so the last thing was just something Zadkiel shared. This was something he maybe, I don't know if he shared it while we were talking about this last week, but I think it's fair to say a lot of people using Terraform Cloud started using Terraform Cloud before there was a mature Terraform Cloud provider. So you might have lots of large configurations in Terraform Cloud, and the thought of defining that in HCL is nice, but yeah, maybe someday. So what I think is really cool about this is it's a vendor specific. So Terraform Cloud has created this tool that is designed to make it easy for you to export your Terraform, your runtime configuration of Cloudflare into Terraform code. So then you can continue managing it moving forward as infrastructure as code. So this was an interesting tip. Haven't dug into it more than that, but I think this is a pretty interesting idea here. You know, there are a few tools out there. I forget what they're called, like Terraformer or some others that help you in a generic sense export AWS to HCL. But maybe some other providers should be doing the same thing that help you export your. Maybe HCL should maybe be the portable exchange format for your configuration somewhere that you should be able to export and then back it up, which is kind of cool too. So, any observations on this?
Massive props to Cloudflare for doing this. I mean, I'm not a user, but I cannot comment on anything else. But the fact that they started with no infrastructure as code, they added that. But not only did they add it, they actually built something to ease the migration. That is amazing, and they deserve major props for this. It's fantastic.
Yeah, it's fantastic. I haven't seen anybody else, any other Terraform provider, as in the technology, do this.
Ali Cloud does something similar, but
oh yeah,
but I think it's all in Chinese.
Oh yeah, probably.
Yeah, I think I saw something on the repos some time ago, but
yeah.
This thing by Cloudflare, as far as I remember, was released very long time ago, like, I don't know, 1 year ago, maybe even more. And it got a lot of attention because they actually have websites where they describe how people should use Terraform. And that's where they get a lot of attention. People shouldn't click in console, but they already clicked in console. So here you are. Now you should do it properly.
Yeah, that is cool. You're right. It was published 2 years ago. This was the first time I'd seen it. So let's see here. I'm gonna share the original link here. There it is. All right. So then, last but not least announcement, and given that there are so many announcements today, we actually might not get to the questions Q&A section, but I think it's worth it for the special guest appearance here by Anton. So Anton, for all of you, you probably already know, he's a major contributor to the other organization of Terraform modules, Terraform, github.com/Terraform AWS modules, and reached out to Cloud Posse, I don't know, a few years ago, and we've stayed in touch ever since then. He's a prolific contributor to the Terraform community and ecosystem. He's an Amazon hero and recognized for all of his evangelism there. And he's a Sweet Ops member. A little bit less frequent these days. Anton was on the very, very first office hours phone call we had back in the day when we called it town hall meetings or something.
Yeah.
But it's good to have you back. The other thing, I guess, while you're here, you have started your own kind of office hour-y kind of thing, or where you talk about various things happening in the Terraform AWS community. If you want to share a link to that later on, feel free.
Yeah, I will. Thanks, Eric. So yeah, you're right. It was a long time ago when we started it, and then I figured out that I have family and enormous amount of other activities. The thing which you mentioned as office hour, which I run, is actually called your weekly dose of Terraform. This is what I have for my time zone, because I'm in Oslo, Norway. And for me, it's much kind of easier to speak at noon. Now it is already 9 o'clock in the evening, and my family doesn't like this so much.
Makes sense.
So nevertheless, I will not take a lot of time. I just want to do two things. So first, I see that here is Lauren Gordon. So big thanks to you that you actually look into some pull requests here and there, and you always find problems. I really like it, because the thing is that I was actually making live stream when I was introducing this bug, and now it is recorded how to introduce bugs, but it has not been recorded how to fix bugs. So at least now when people will watch it, they will see, okay, this is how we have to make bugs. Okay, let me focus on just serverless with Terraform. So the website, which...
If you want to share your screen, you can go ahead. I just stopped sharing.
Yeah. Okay, yes. I can share my screen. This one. So here is it. I want to talk specifically about this project, serverless TF. So what is serverless TF? As you can imagine by name, it is doing serverless with Terraform. I want to explain why I actually started this project and what this project actually consists of. So I'm not sure if I use a lot of words frameworks here, because when I was making this one, I looked into definition of what does framework mean. And framework actually means not just tool, but it's actually a concept, it's a way of doing something. So it is not CLI, it's not any shell script or Python or anything like that. It just concept describes how things can be done and what are actually the problems with existing solutions. So in my company, which is called Better Job, we do a lot of serverless nowadays. Primarily because it's cool, and I don't like to manage VPC resources anymore. And the thing with existing solutions is that when we started using it, so we have few projects where we use serverless framework, and we always felt like this doesn't belong here. We understand two things: how to write Terraform code and how to write Python code. That's it. We don't know anything of Node.js ecosystem. And if we want to do something, please don't let us to learn how Node.js work or how plugins has to be added. So this is definitely not what we wanted. There were already many different things available, like framework to write this code, which actually generate some TF code or CloudFormation code for you as well, which is, well, I don't really want it. And then there are tools for infrastructure management, and then we use something to do application deployment. So in serverless TF approach, we just decided that everything what we have is just one big graph. And we want to let Terraform to go through this graph and make all of this as one big bang, let's say, comprehensive infrastructure management, and to do serverless application deployment. Because all our infrastructure in serverless consists of different infrastructure resources and application code. That's it. It doesn't contain anything about plugins because we use just Terraform resources natively. So there is no need for us to think about concepts which are introduced by any of serverless application frameworks. And initially it was like a little bit too much. So we thought like, okay, we probably need to use Terraform and we need to use some sort of application framework which will help us to write this application code. It turned out that the most useful framework is the smallest one. So we like AWS Chalice, which is very, very small and very minimalistic. It has some relation to CloudFormation or to Terraform, but it's so optional that we can easily disable it. So we use TerraGrant. It says use Terraform with or without TerraGrant. Well, we use TerraGrant quite extensively all the time. And then there was a dilemma between Terraform and CloudFormation sorry, not Terraform and serverless framework, where this resource has to be defined. Like API gateway, where does it belong? Well, it belongs only to serverless resources. So naturally, it has to be part of application framework, right? Okay, but what if I want to make like shared resources like VPC? Because you can create them inside of your serverless framework as well, but traditionally we create them using Terraform. So, and there are a lot of situations when you actually don't think or don't know where to write this. For example, DynamoDB. Does it belong to serverless application or does it belong to your traditional shared stack? So instead of thinking about where to put this resource, we just write code in Terraform, and now all what is related to infrastructure management actually defined as Terraform or TerraGrant. This one I don't really agree anymore because local stack is not great, especially free version. But it is possible to run a similar copy of your environment locally if you wish. We are using different services which cost money on local stack, so we didn't bother to go with this approach. So most likely I will remove this text, but it is still a rather slow application development lifecycle with any of existing solutions like serverless framework. There are a few solutions in serverless framework approach like serverless components, which they're developing, and a bunch of different shortcuts which you can take. The point here is that we want to write code and we want to see a result as soon as possible. And applying this without generating crazy amount of CloudFormation code, then wait for something, we don't really want. We just want to run Terraform apply, and as soon as it finishes, the code should be deployed. So local stack is not actually helping us so much. And this one was a really big one. When we wanted to add functionality to serverless framework, I don't want to learn JavaScript. Really, don't make me to look into JavaScript code if you don't want me to cry. Honestly, this is one technology which I don't want to add simply because a tool which I'm using has plugin written in that technology. So this is really important that our technology stack is not including JavaScript. So if we want to add functionality to add, let's say, AppSync or new features into API gateway, we don't want to write code and then maintain it somehow. We want to write Terraform because resources which we are going to add are part of infrastructure. So again, Terraform is native choice here. And then I already have contributed and used a lot of Terraform AWS modules, so which is just natural for me to continue using them. While doing this, I added few other modules like AWS AppSync to support. I think actually now it supports. Now it supports all features of AppSync, including all ways of authentication, all kind of resources, resolver, data sources, and so on. And then I added another module which was also relevant for serverless, which is CloudFront. Again, CloudFront is used with Lambda at Edge and so on. So AWS Lambda is a core component in all of this. So let me just scroll through this. Well, there are a lot of modules which existed before, but we added AWS Code Deploy because we wanted to deploy this again using just code. We just run Terraform apply, wait a few minutes, and then this Lambda function or set of resources which Terraform decided to be related updates. That's it. Again, we rely on Terraform all the time to manage our infrastructure, and now we just add another resource which is called Lambda function, for example. It has a bunch of dependencies which are described already. So let Terraform to resolve this somehow. So let me show this source code of Lambda module. So this Lambda module was created with an idea that we want to be able to do everything what is related to AWS Lambda tasks, like building dependencies in Docker, without Docker, private repos, public repos, doesn't matter. Then we want to take care of packages. We want to have them locally, or we want to upload them on S3. Then we want to make sure that we actually update this Lambda function every time when something changes in dependencies. This is still a little bit tricky part sometimes. And then we want to do deployments using submodule, which is called, somewhere here, it's called deploy. So yeah, there is module, which is called deploy. So in fact, there are a lot of different combinations. I call them countless, but of course you can count them. And overall, I look into this as like the most complicated piece, because this module takes into account Terraform lifecycle as well. So for example, when we run Terraform plan, what do we expect? Well, we were told that nothing will be created. So that's true. No resources, no zip archive, nothing will be created because you run plan. What happens if you remove this plan? Well, this plan has to be not created again, and there shouldn't be any hard failure. It should resolve somehow. A lot of magic has been placed into a package Py script, which is now pretty long, but it's quite easy to understand when we are working with it. So, and also there are a lot of different examples which show how these can be used. For example, if I go to complete, well, complete usually shock people, because there is one function with enormous amount of input parameters, and in fact, of course, normally we don't use all of this. But it just, it's supposed to show you amount of features which are inside. Normally, when we deploy Lambda function, the code looks like this. So we just specify, okay, this is for layer. So the code looks like this: function name, source, do we want to publish it? That's it. So not much, not a lot of things different. But amount of all of these combinations and options and different dependencies is just crazy. So when we started working on this module, we obviously looked at existing solutions, and then we figured out that, okay, the best solution which we found has a lot of challenges. Like I think the one by ClaraNet, I think Clara, well, I don't remember Clara. Anyway, I think it was
You're
mentioned.
right, the one by Clarinet, yeah.
Yeah, so they have a lot of open issues. And we looked at those issues and we figured out that the whole approach which is implemented in that module has to be implemented like one more time, completely. Because we understand, we take into account Terraform lifecycle. Like plan, apply, destroy is essential here. We cannot just say like, oh yeah, we are building Lambda function, so we assume that you have this source code available. No, if this source code is not available and you run plan, fine, you don't need it right now. But if you run apply, then yes, we will check it out and we will see that something is missing or some arguments are not correct. So amount of values which we have somewhere in package. is just crazy. So here is a relation between external data source, including all of its strange behavior, local file, which contains information about what is actually about to happen. It's really helpful for debug. And then we actually rely on null resource to create an archive. We cannot rely on traditional, zip archive or some sort of built-in resource, because it lacks significant amount of features, like excludes like enormous amount of features. I don't remember right now, but we couldn't use it. So that's why there are a lot of strange dependencies everywhere. Now I say that it works, but when I don't work on this project for some time, I forget how it's built. So luckily there are examples, and I'm sure that you guys understand what I mean by forgetting how things were built. For me, this happens quite often when I switch focus and I forgot how things were created or who made it, and then I see my name. Oh, okay.
That's how it is.
So, yeah.
More projects.
So I encourage you to check out this one, and amount of features which we put here, an amount of integrations with not just HTTP API gateway, but also with AppSync and CloudFront and so on, is pretty big. So I tried to write documentation and actually explain how to do different things like debugging, how packaging actually works, and so on.
So let's take a pause there for a moment and let's see. I'm sure there's some questions here. Maybe anybody have some questions for Anton and his implementation here of the serverless style framework?
This is Sheldon. I've actually been working through this this last few weeks. Have not used your solution yet. I'm definitely going to go try it out. What I would like to know is that one of the reasons for me that being new to Lambda, that I haven't gained much momentum on doing a lot more, is the plumbing, right? You know, getting all of the steps, all the permissions and setup. And the serverless CLI, my first attempts with it were pretty straightforward, pretty nice, as nice as it could be using something that I prefer to use Terraform in. What I would like to know is just on a very high level, if somebody is familiar with Terraform, they're not familiar with Node, anything like that, but I'm not creating plugins. Where do you see the benefit of approaching it with a module like this versus something like the serverless CLI? What's the sales pitch in a way that helps me, you know, decide what fits my use case better?
Well, I think the best sales pitch, which at least stick in my head, is that Werner Vogel told us that serverless should be easy. But talking about serverless and dreaming about serverless is totally opposite of using existing serverless ecosystem tools. So you manage to do your job quite easily, straightforward, using serverless framework. But if you continue doing that, and if you suddenly decide to expand it, you will have to go deeper, 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 and fix plugins and try to debug something. And it's just much, much slower than traditional case which we have with Terraform.
That was my experience with serverless also. I started using it a while back, and yeah, it looks real good when you first get started. It's very, very easy. But then as soon as you need to do something that is just outside of whatever plugins you chose, you know, actually support, like you got to go, you know, learn that JavaScript and really dive in to figure out, you know, how to adjust it to address your use case. Whereas with Terraform, you know, like it's all in Terraform. It's exposing the entire AWS API to you. You can do exactly what you can do with AWS and the AWS console, you know, in Terraform. So it's way more powerful, gives you a lot more control.
And in the
One
end,
other question: does this run in Terraform Cloud, or is it do a lot of local provisioner type actions that require it to run locally?
Well, today I was trying to figure out this. There are Terraform Cloud agents which cost money. And this is the only way how you can install Python there. From what I understand, there is no easy way to provide your own dependencies. So Python is required.
You can bundle all the binaries and things you need in your repo, and if it's totally what's the word I'm looking for? Self-contained, it'll work, but that's not scalable.
Well, you can also do something crazy. We can elaborate on this. So here is this piece of Terraform Cloud Agent. So you have to use this TFC agent latest and then just install Python 3.8.
That's with the agent, but like if you're just going to use open source Terraform, not open source, but the public Terraform Cloud, not including runners, then yeah, that would be tricky.
Well, you can do this still, but that's definitely ugly and probably outside of this scope.
Yeah.
There's kind of an interesting way to get anything you want into Terraform. Also, you can create a module that contains exactly what you want, but that has no Terraform code, right? And then you include that module as the source in your main.tf, and it will go download that Git repo for you and pull it local.
I like it. That's a pretty clever hack to do
It's
it.
definitely a hack. But it's kind of a fun way of vendoring. Like, I wanted to. There's some JavaScript-based Lambda, that I want to deploy using Terraform. So I put a module around it as the source, as the Git repo. It pulls it in for me, and then I set that as the source path for the Terraform code.
Yeah. I have a question for you, Anton. I'm curious. When I saw you going down the path in the intro there, and I saw you were introducing code deploy, and you were using that as part of the solution, I got excited because I thought maybe what you were going to do was because the local exec thing. I get it. I know why you're doing it. Been there. We're doing it for some things. But what I was hoping to see was that you use something with like code build or code pipeline or something like that to construct the artifacts in such a way where you have no local dependencies other than the Terraform binary.
This will take time. That's what I don't, and this will introduce different dependencies in between. What I can do is that if I uncomment this block, this is like playground where I have a bunch of things in one place. And if I do deployment here, then here I just specify which version I want to deploy and what else. And just apply this change.
Okay, so that's kind of doing the remote build that I'm talking about.
But this is going to be using code deploy through AWS. Yeah, I think I use AWS CLI here to do that.
Oh, okay. So it's shelling out to AWS CLI.
Yeah.
But then running the rest remotely.
And here is also wait deployment completion equal true, which means that I will actually sit and wait until this Lambda canary deployment deploys everything.
Yeah.
So which is a pretty effective way for me to sit and do nothing and just sit and wait and wait. So normally I set wait deployment completion to false and continue doing my other things. So this one.
Yeah.
If you haven't seen it yet, the original maintainer of the Clarinet Lambda module, his name's Raymond Butcher. He's in the SuiteOps Slack also.
Oh, cool.
So he's created another Lambda module under his own GitHub account called AWS Terraform AWS Lambda Builder, and it is actually doing that. It's using a Lambda function to build the Lambda function, or optionally a code build project.
Okay.
To build the Lambda function. Yeah.
Yeah, it's actually very interesting that you mentioned this, because when we were writing this Python code and crazy amount of dependencies, we were really looking forward to see and to figure out why it is so hard to do with Terraform. Because okay, Terraform was not designed for this. Fine, I get it. Then I was looking for something like Terraform, AWS Lambda provider. So there is a special provider for just that provider.
Wait, like executing lambdas to run arbitrary things and get the out?
No, it's actually to this one, AWS Lambda. What is it? Resources. So invoke custom Lambda function. And I was really thinking that there should be some sort of higher structure inside of native AWS provider where we can say like, hey, this is archive. I want this function to be created. Mm-hmm. In fact, we need to connect all of this packaging, building, and so on. That's where Pulumi say like, guys, take my beer and we will do this properly, as well as AWS CDK.
Yeah.
So yeah, I'm looking forward when this AWS Lambda provider, I mean, of course, with significantly different features, but when Lambda resources will be properly integrated and supported inside of AWS provider. Because what we do now definitely not gonna to be acceptable for people who cannot or don't want to install Python.
Yeah.
So I don't know how to explain to them that, hey, Python is good, please install it. One more thing which I kind of forgot to say is that when you go to serverless TF and you read some basic things which I just went through, you can click on the link and read more about all of these steps in details, like why this was built and what is actually, law of conversion of complexity. You see, I was using Wikipedia to find this link. So you can read about this and probably it will give a little bit bigger picture of how Terraform fits to this field. So I put a little bit more information here, including development workflows and how things are connected together, and using commands like SAM build, because I was actually considering to look into SAM build more, but then I discovered that it's, again, not good choice for us, and so on. So check it out. It's a little bit long, but I think it's helpful.
That's really helpful that you documented all that research and design considerations that went into it and what led you down the path.
Yeah, now we are actually using it. So I have to update it a little bit and remove some sections because I was over optimistic at some point on certain things like local stack, for example, which is absolutely not good fit for this case. So yeah.
Local stack is a good fit for very few use cases. It's local stack and Minikube are the bane of my existence.
Yeah, generally agree with that. I think the promise is different from the reality, maybe.
Yes.
Well, thank you guys so much for participating today, and Anton doing that deep dive into your thought process and how you implemented the serverless TF thing. I think that's of great interest to our community and anybody using Terraform and wanting to do more with Lambdas. With that said, everybody check out Anton's own weekly or monthly podcast. There's a link here somewhere. I'm sure.
Not yet. I will put it now.
Okay, cool. And we are at the end of the hour for today. I think we need to wrap things up. Remember, everyone, to register for our weekly office hours if you haven't already. Go to cloudposse.com/office hours. Again, that's cloudposse.com/office hours to register. If you liked what you heard today and you'd want to have a one-on-one session with me or someone here at Cloud Posse, feel free to go over to cloudposse.com/quiz. Again, that's cloudposse.com/quiz, and I look forward to talking with you. Thanks everyone for sharing. We always learn so much on these calls. A recording of this call will be posted in the Office Hours channel in a couple hours and syndicated to our podcast at podcast.cloudposse.com. Again, that's podcast.cloudposse.com. See you all next week, same place, same time.
Bye.
Thanks, Anton.